Hey folks, Ken here, host of the Level Up podcast. This week we're sharing a talk I gave at DevOps Live in London earlier this year. The talk is centered around the shift left movement, what this means for platform teams, and what you should look for in an internal developer portal. I hope you enjoy. Hi everybody. This is Beyond the Hype, a practical guide to internal developer portals. So this talk is really going to be in two parts. So in the first part, I want to talk a lot about the hype surrounding internal developer portals, or IDPs, right? IDPs have had a lot of accolades, interest, and investment over the last few years. And so I want to touch on that, but I also want to move past it and get into an actual practical guide for what to look for and how to evaluate an internal developer portal. Now, I have an assumption baked into the title of this talk that everybody here knows what an internal developer portal is, and I kind of want to check myself on that. So I want to do a quick audience survey. How many people here work in a software company of some kind? Quick show of hands. Okay, a lot of you. Excellent. How many people here work in a large software company, right? Large can mean sort of whatever you want it to mean. Okay, some. That's good. How many people here identify as a developer? All right, good number of you. And how many people here have heard of the term internal developer portal? Maybe you've heard a specific one, Backstage or OpsLevel. All right, a lot of you as well. Excellent. So a little bit about myself. My name is Ken Rose. Years ago, I worked at a company called PagerDuty. If you've ever been on call, you've probably been woken up in the night by some code I wrote. I then worked at a small Canadian e-commerce company called Shopify and led a lot of their API and platform efforts. And then my co-founder and I started OpsLevel back in 2018. You can probably tell from my accent, I'm not from around these parts. I come from Toronto in Canada, but I'm just thrilled to be in London and here with all of you today. So I want to talk about the problem of complexity in software. Especially in large organizations, software is just becoming more complex. And this complexity can be broken down into two different categories. The first is just around the surface area of software, right? With the growth of patterns like microservices, with additional applications, there's just more stuff running. So I'm going to take as an example this image here, right? This is from Uber's distributed tracing output. They were using Jaeger at the time. This is from SRECon 2019. And holy crap, it's huge. And their architecture has grown since then, right? Of the people who identified as a developer earlier, how many of you think you could draw a picture of your own software architecture on a single whiteboard? No one. I see a lot of there's no way that could ever happen, right? I'm actually assuming that your architecture might be simpler than this. Now, the second aspect I want to talk about with regards to complexity is what I'm going to call role complexity, right? The life of a developer used to be easy. The only thing they had to do was write code. It used to be like this. Just what does this code do? But the role has shifted now. I think this is a clearer set of the things that modern product developers have to think about, right? With the advent of DevOps and shifting left, we're now asking developers to do more than ever, right? In addition to developers having to be proficient in the craft of software development, think writing code, writing tests, application architecture. They also have to know a whole bunch about operability concerns, observability, incident management, Docker, all the things that are listed on here, right? Developers today are being asked to do too much and they have to keep more and more in their head. And if I wear my SRE hat, if I think about what's the core reason why performance issues creep in applications, why reliability issues creep in applications, why incident management processes aren't always followed, it's not because developers want to do a bad job. It's systemic, right? It's a tall order to ask developers to be accomplished in all these different domains. Actually, of the developers again in this room, how many of you use more than 5 different tools to do your job? Yep, pretty much all of you, right? You have to deploy to production, there's a tool for that. You have to restart CI because you had a flaky test, there's a different tool for that. Going on call, you might use PagerDuty or one of the many other offerings out there. Debugging production issues, there's an error tracker you have to use. Instrumenting databases or profiling your code, there's performance management tools. There's a myriad of responsibilities and tools. And so the way that a lot of organizations think about managing this complexity is they create a new team, right? This idea of a platform team. Now, sometimes they call this team another name, right? I've seen this team be called the core infrastructure team. It can be called foundation engineering, the SRE team, tech ops, the DevOps team. It can be a dev experience team, but the essence is the same, right? We've talked about product developers and the challenges that they face. That's that group on the top, right? These are the teams that own individual microservices and they ship whatever value it is your company delivers to your end users. But supporting those product developers is that underlying platform team. And this is an internally focused engineering team that has as its customers the other product development teams in the organization. And platform teams exist as a source of leverage in an engineering organization, right? Their goal is to make product teams more efficient by solving those cross-cutting and repeated problems that all these product teams are facing. right? You don't want to have duplication of effort with each of these product teams independently reinventing the wheel and figuring things out like how CI and CD should work, or how to provision infrastructure, or how preview environments should be set up. You want to consolidate those responsibilities on a single underlying platform team. And this platform team ships its own product that is then used by these product teams to ship faster themselves. So let's think about what that product would look like and how that can help reduce the complexity faced by product developers. Again, platform teams are focusing on those cross-cutting initiatives to allow product developers to ship with minimal overhead. And at the lowest level, instead of providing developers sort of raw access to infrastructure and all the associated complexity of cloud environments, platform teams invest in creating some kind of internal application or infrastructure platform. So developers then don't have to know about networking and operating systems and Kubernetes. Instead, this internal platform abstracts away a lot of those low-level infrastructure details and provides a simpler interface for developers with good out-of-the-box defaults. Now, in addition, platform teams invest in providing a frictionless and self-serve developer experience on top of that app or infra platform. And there's generally a system of APIs, of tools, of services, of documentation, of patterns, of standards, of support, and they're arranged together to enable product teams, again, to ship value faster and with reduced coordination. And this is the key part. The most effective platform teams apply product management principles and treat product developers as their end user. So they bundle that system as a compelling internal product, and that is an internal developer portal. And again, this internal developer portal allows these autonomous product development teams to ship new feature faster and with reduced overhead. Now, if this feels a bit abstract, I promise you I'm going to concretize it soon with some specifics. But I do want to talk a little bit about the hype that both platform engineering and internal developer portals have had. So this first graph here is from Gartner's hype cycle for software engineering for 2023. How many people here have heard of Gartner or know about it? A lot of hands. Yeah, okay, pretty much all of it. But just for those who don't, Gartner is a world-leading market analysis, research, and advisory firm. And they annually release a hype cycle across a variety of domains, including software engineering. And many executives and large businesses make their technology and purchasing decisions based on Gartner's analysis of where the market is going. So what we'll observe is the hype cycle for 2023, outlined in red there, both IDPs and platform engineering are on that upward crest in the innovation trigger phase. That means, well, they're still early in their maturity, but it's up and to the right in terms of mind share and adoption. They're growing. I also have on the right just 10 companies that happen to use IDPs, and some of these are pretty well-known brands. There are hundreds more. In terms of where the market is going and the impact IDPs are expected to have, two other quotes from Gartner. From one report, by 2026, 80% of large software engineering organizations will establish platform engineering teams. The quote goes on then to say to enable product teams to move faster and ship more high-quality software quickly. The second quote is by 2026, 75% of organizations with platform engineering teams will provide internal developer portals. So let's take those two numbers. 2 years from now, 80% of large organizations are going to have a platform engineering team. 75% of organizations with platform teams will have an IDP. That means 2 years from now, 60% of large software companies are going to have an internal developer portal. 2 years from now, if you're working at a large software company, there is a 60% chance you're going to have an IDP in place if there isn't one there already. That's huge. So Gartner's right here. Platform engineering and developer portals are seeing increased adoption. And there's this desire to believe that IDPs are going to revolutionize how your product development teams are going to work together. And they definitely can, right? When managed properly, they enable efficient product delivery. But IDPs are a tool. And as with all tools, they have to be configured correctly. You can't just drop an IDP in or rub an IDP on your organization and just sort of expect favorable outcomes to magically occur. So in this next part, I want to talk a little bit about how you should set up an IDP properly, right? What are the things you should look for? And I want to talk about the main areas you should think about with internal developer portals to maximize your chances for success. I think of an internal developer portal as being broken down into 3 different pillars. There's a pillar around visibility, there's a pillar around standards, and there's a pillar around self-service. And I'm going to be talking about each of these pillars individually in turn, but an important observation is that all 3 of these pillars need to rest on this underlying fabric of automation. They are shrouded in automation. If you try to approach any of these pillars with manual operations, it is unlikely you're going to be successful. So let's dive into each of these pillars and understand how automation is going to help us.
Hey folks, forgive the interruption, but I wanted to make sure you knew about the OpsLevel developer portal. I may be biased because our team did build the thing, but it is a game-changing way to improve your engineering team's efficiency. Teams can save hundreds of hours each week so they can focus on building more products and meeting market demand. OpsLevel has helped solve problems for teams at Duolingo, Keller Williams, and Okta, and we want to help you next. If you're looking for a central hub for your developers to build, maintain, and fix software, check us out by visiting OpsLevel.com.
So the first pillar I want to talk about is visibility, right? You have all these services, you have all these teams, you have all this infrastructure, you have this gigantic production architecture. You need an authoritative list or catalog of everything that's out there in prod. And here is what that looks like, right? In its most basic form, it's these two main columns, the name and the owner. What's out there? Who owns it? And you have to approach the generation of this catalog through automation. I'm going to touch more on that. But I want to point out that this catalog is a solution to that challenge of surface area complexity. It's an up-to-date, accurate, and complete catalog of everything in your production architecture. No one on your team has to try to remember every single service anymore. So if you're onboarding a new developer to give them the lay of the land, or if you're a veteran developer that needs more information about parts of prod that you don't access often, you have all the necessary info in one place. In addition to a list of services, there's also metadata that we can collect about each service, right? Here are the basics about who to talk to. If you're trying to figure out which team is responsible for something and how you contact them, there's their email address or Slack channel. You can see in the top right there who's on call for the service. You have links to the code. We can collect additional metadata as well. There's an operations tab where we can have all of the tools that are used to manage this service all consolidated in a single place. If you need to find where is the Datadog dashboards for a given service, or where can I find the Confluence documentation, or where can I find the deployments and information about that, it's all consolidated on the left. I can also see recent deployments that happened on the service. If we're having some flakiness or we're seeing an elevated spike in errors, I can quickly find out for this service or any others in my production infrastructure, what were the last things that were recently deployed. There's also tabs around dependencies to be able to understand how this service relates to others. There's abilities to inline API documentation. What you have is a little portal or a little homepage about every single service that's running inside of your production infrastructure. Now, I want to talk about different ways to actually build that service catalog. Most organizations will start with trying to do this with a spreadsheet, and that quickly becomes untenable as their scale grows. An approach that feels very natural for a lot of platform engineers is, config as code, right? We'll write YAML files. We'll take what is normally a single large spreadsheet, we'll partition it, and we'll give each row or a handful of rows to the teams that own it and have them write YAML files, have them write these little manifests that exist inside of their repos that define, here's what a service should do. And you can be successful with that. It is possible, but it's extremely difficult because the main stumbling block that occurs, the main challenge that organizations face when they try to build a service catalog with YAML files is that developers just don't keep the data up to date. They have other priorities or their incentives aren't in place for them to keep that data up to date. So they just don't. They do other work instead. But the problem with that is that erodes trust in the quality of the data in your catalog. If you can't trust it in your catalog, then you get this feedback loop of, well, no one trusts the data, so no one's using the catalog, and that just degrades the experience of people trying to get access to the information that's there. So as an engineer, though, I think a lot about, well, how do we automate this? And a better way to build a catalog is to appeal to that automation. As an example, if I were to look at your GitHub repos, I could look at some of them and start to say, well, this repo, it has a Docker file. It looks like it's written in Rails. It looks like it's producing an artifact. This is probably a service. Here's another one that's written in Java. It looks like it's a library. And I can start to figure out a whole lot of information just by looking only at your source code. If I then start to layer on other signals, if I start to layer on, well, let me now look at SonarQube and look at the projects that you have and what vulnerabilities you're finding. I can get more information about what does the topology of your service landscape start to look like. If I tie into the event stream, into Kubernetes, I can start to get more information. If I look at the artifacts that are being built by Jenkins or any of your CI tooling, I can quickly start to thread this needle. And that's what this red line is sort of highlighting here. I can thread this needle through all the tools that you have in your production infrastructure to automatically build and maintain a catalog and keep it up to date. Slurp in as much data as possible from the existing tools you're already using to infer what services and teams exist. Now, the next pillar I want to talk about is standards. And there's a sort of dichotomy that exists around standards, right? We talked about autonomous product development teams. We talked about you build it, you own it, teams being able to make appropriate technology decisions for the software they have to build. That's great. But at the same time, if I wear my platform engineering hat, there needs to be some notion of standards or guardrails for how those systems are built, right? I'd like to have some base level requirements to ensure that I want to ensure are upheld across the entirety of production, right? I want to have confidence that our site is reliable and secure because we are consistently using the battle-tested patterns that we have. So let's see what that kind of looks like. So here is a simple example of something we call checks. At this bronze level, there's 3 passing checks. Is there an owner defined? Is there a log tool defined? Is it Splunk? Is there an incident management defined? Is it PagerDuty? There's also a failing Ruby version check, right? This service is supposed to be on a minimum version of Ruby, and it's not. Now, an important aspect for how these checks are defined is that they're defined through automation and through integration. What you don't want to have, let's take this failing Ruby version check as an example. Great, so the developer has to go upgrade Ruby, and they do that. It sucks for that developer then have to go back to some other tool and check a box or do something or say, yep, I did this. right? That's toil. We want to avoid that for developers' lives. So instead, let's do this through integration. It might be hard to see here, but that Ruby version is a link that actually is integrated into a GitHub repo and looking at that file. When the developer actually does the work and actually upgrades the Ruby version, this check can reevaluate automatically. If you don't want to integrate with your source code, you can also integrate with your package management system or with your version control system. But the goal is the same. You want to have that the evidence of a check being completed is in the integration itself. It's as an artifact of the work actually being done, not a result of a human coming back and anointing, yes, I have done this work myself. I also want to point out these checks are actionable for developers, right? I'll observe the first, there is a sequence of checks and they're graduated, right? There's a bronze level, there's a silver level, and that graduation provides prioritization. Developers should work on checks that are in bronze before they take on things in silver. And it's clear for developers how they can get from one level to the next. The second aspect is that for each check, there's context on what it is, why it's important, and how to fix it. It's literally spelled out, what do I need to do, right? And that built-in documentation reduces confusion for developers and increases the likelihood that checks actually get completed. Now, this is a sequence of checks for a given service. You also want to get visibility across your entire infrastructure. So this is a view for platform engineers or management to see, well, we have all these standards and checks defined. What are the areas that we're deficient? Where do we need to invest? You can slice and dice this by team, by group, by system, by whatever dimension sort of matters for your organization. But I'll highlight that checks live in different categories. So on the top right there is security, reliability, scalability, observability. And we can see here as an example, security is currently at 30% bronze. That doesn't seem great, right? And it opens up a question, well, why is that? It might be that the standards are defined too high, that the checks we have are somewhat insurmountable for our team. It could also just be that developers are prioritizing things that aren't security. They're doing other work instead. And this is a sign that we as an organization need to invest in security so we can improve our security posture. In addition to a snapshot, you can also see trends over time, right? You can see that here over time, we have new services being added, our estate is growing, but also the overall quality is getting better. That gray bar is the number of services that aren't even at bronze, they're in beginner, and that's trending down over time. That's really good. Now, a final aspect to think about standardization is actually how to change and improve your standards, right? How do you raise the minimum version of a required library? We're migrating from Spring Boot 2 to Spring Boot 3. How do you migrate teams to a new cloud provider? How do you switch out a CI tool? Let's say we're migrating from Jenkins to Circle CI. And the simplest way to orchestrate this through automation is with this idea of campaigns, right? Take that same check infrastructure that's powered by integrations and provide a way for developers to onboard onto this new standard. So I have a pretty classic example migration here of moving tier 1 services to a new deployment pipeline. And like with checks, there's context on what this campaign is and why it's important. There is a burn-up chart to show the progress. This campaign actually is not doing so well in the burn-up chart. It's getting a little bit closer to the end date there. And I think teams are gonna have to swoop in and pull the nose up. And there's also an ability to send reminders to teams, the email or Slack that this campaign is underway. And please prioritize the work because we are approaching that target end date. And I want to really reinforce the power of automation here, right? Think about how you normally run a campaign. There's no spreadsheet that you have to manually collect this data. It's collected automatically through integration. There's no manual program management stuff to continually ask teams and harangue them like, have you done the work yet? Right? That weekly 30-minute status meeting that you have with all your tech leads, gone, right? Instead, you have scheduled notifications and reminders. If you really need, hey, you have a button to escalate and you can send a reminder. So campaigns leverage the fact that we have this automated catalog already of what's out there and who owns it. And being able to run a campaign or initiative against some or all the teams and know that that work is going to the right service owners and the right teams to get that work done. So the final pillar I want to talk about is developer self-service. So there's sort of two different challenges around self-service, right? One for product developers and one for platform engineers. We talked about product developers and we talked about role complexity, right? DevOps, you build it, you own it, shift left, took out what was previously operational considerations and stuffed them onto product developers and moved that further up in the SDLC. Right? They have to know the craft of software development and the craft of operations. So as an example, a product developer has a bug in their code and they need to roll back. Great. Where do they roll back? Do they go to their CD tool? Where's the rollback button? Are they sure they have the right tag set up that they're rolling back the right image? They need to scale their pods because their autoscaler is not working properly. What's the kubectl command? Oh yeah, which is the exact flag they have to pass in? Oh crap, are they connected to VPN? And you can try to document this stuff in runbooks, but that also presupposes that developers know to actually go look there. For platform engineers want to enable developers and not just be inundated with tactical requests. I've unfortunately seen this pattern occur where I'm going to call it platform engineering teams are instead kind of drowning in this ticket soup, right? So as an example, a product team wants to create a new service and they need a new S3 bucket provision. They file a Jira ticket, it goes over the fence to the platform team, and the platform team creates an S3 bucket for them. And then they have to create a Kafka topic for some other group. And then they have to create some new infrastructure for some other team. And instead of actually enabling developers, they're just stuck in this loop of constantly responding to tactical requests. So, there's that quote, right? Give a man a fish, feed them for a day, teach a man to fish, feed them right. So platform teams shouldn't be like just handing out fish one at a time, tactically responding to each of these individual Jira tickets. They should be making, an automated fishing rod. They want to be able to allow those product teams, investing in automation to allow those product teams to be able to self-serve. So that's the solution to this problem, right? Automate those common operations and make them discoverable. So 2 examples here. The first example I want to talk about is service templates. So think about how new services are normally created in an organization. You're a product team. You will take the last service your team built. You will clone that repo. You'll do your best job to get rid of all the business logic. And you'll be left with some shell that has maybe some configuration, some initialization, maybe service discovery. But the problem is that each team is going to do that a little bit differently. And you're going to have divergence across your estate, right? You have no guarantee that anybody's sticking to any kind of standards. You have no idea what version or what service that team used as their baseline to create their new service. So the alternative is investing in service templates, right? Templatizing what authoritatively a new Java service should look like, or a new Ruby service should look like. Here's a set of libraries I should be using. Here's the service discovery mechanism. Here's the configuration. Here is everything templatized. Developers can then fill out a simple form like this, and in 2 or 3 clicks, they get a newly minted repo that has all the necessary boilerplate that's adhering to those best practices we talked about earlier. Platform teams can also invest in additional automation to also provision infrastructure, provision additional resources. So that way developers can get just straight to writing business logic and not worrying about all the other bits. Another type of self-service automation is automating the common actions that developers have to do. For example, I need to, as a developer, create a new Kafka topic, or I want to create a new S3 bucket, or I want to provision a new database. Make that accessible. Make it discoverable for developers. You don't want developers to have to remember yet another CLI command. It's there in the UI. It has type ahead search. It's easy to find, and it's self-documenting. This also helps provide boundaries and standards, right? You may have, let's say, naming standards for your Kafka topics. We want them to be kebab cased. Great. You can apply validation as part of that create Kafka topic action because everything is coming through that centralized UI. Another example that's not on here actually is provisioning your database. But we don't want developers to accidentally create an M5 4XL that's burning $2,000 a month for a hack day project because they forgot to tore it down afterwards. Not that that's ever happened, right? We want to be able to enforce standards, right? We might say as an organization, the max size that developers can provision is an XL. If you need more than that, come talk to us. But you're able to have that kind of validation. And the validation can exist because developers can self-serve through this action front door in a unified portal. So I'd like to conclude, right? We talked about platform engineering and we talked about IDPs and we talked about what to look for in an IDP. Now, if you're in a small team, if you today can fit all of production in your head, you probably don't need a lot of the tooling or these practices just yet. But if you're in a company with a large production infrastructure, if you have engineers in your organization that you don't get the chance to talk to every week, if you have any kind of complexity at all, an IDP may be for you, right? And an IDP is that key part of a product offering from platform teams to other developers in an organization. It lets those developers quickly deliver quality software. And this results in faster and more efficient product delivery. This allows you to reduce your toil for all of your engineers, both your product developers and your platform engineers. And most importantly, this increases leverage across the engineering organization to improve software quality through standardization. Now, I'd be remiss if I didn't talk about OpsLevel. We make an internal developer portal. It started in 2018 and we have a lot of customers and our booth is just outside. We're at booth L160. You literally can't miss it as you exit. So I'm happy to take any questions now or afterwards if you want to find us at the booth, but I'd like to thank everybody very much.